For today's lesson, we're going to be using an example from the textbook, page 268, path of a ball. So you can pause the video and have everyone take out their textbook and turn to that page. Assuming you have it open in front of you, the path of a ball is modeled by the equation y equals negative x squared plus 2x plus 3, where x is the horizontal distance in meters from a fence and y is the height in meters above the ground. There's two questions and I'll add a third. What is the maximum height of the ball and at what horizontal distance does it occur? So that's the key word here. For these questions we're looking for the keyword max or min, and that just means that we're looking for the vertex. Now if we're looking for the vertex, that means we should convert this to vertex form. So first we're asking for max height. The second question is asking for sketching a graph. And I'm going to add two more things, even though they're not on this question. When does it hit the ground? And at what height is it launched from? Feel free to pause the video as we're going if you need to copy. I'm just going to be moving through this quickly. So for max height, we're going to convert to vertex form by completing the square. Hopefully when I say that, that doesn't freak anybody out. We start by factoring out the negative 1 from both the first two terms. Then we're going to take that second term, we're going to divide it by 2, so we get minus 1. Then we're going to take minus 1 and square it and get 1. So we're able to artificially create a perfect square trinomial. And then to get that minus 1 out of the brackets, we have to multiply it by the minus 1 out front. Very good. And we can factor this in one step, and we can collect like terms. So we get minus 1, x minus 1 squared plus 5. So if it's in vertex form, then we know that the y value of the vertex is 5. So the max height is 5. Okay. Sketching this graph, why don't we do that last? So for for C then, when does it hit the ground? Well, hitting the ground is when the height is 0. So at what horizontal, so I said when, often these are a function of time, but this is a function of horizontal distance, so that's fine. So where, at what x coordinate, at what horizontal distance does it hit the ground? So that just means where this, where height is equal to 0. So we're going to set this function to 0, negative x squared plus 2x plus 3. So we know how to factor this, right? You multiply by the first times the last, you get minus 3. So what adds to minus 3, or sorry, adds to 2 and multiplies to minus 3. So we get plus 3x minus x plus 3. Looks like we can factor out a minus x from the first two terms, which leaves us with an x minus 3. Factor an x, or minus 1, so we get x minus 1. And I'm worried that I'm not actually recording audio. I hope we are. So we can have a common factor of x minus 3, and we get minus x minus 1. We should factor out that minus 1 from the second term here, so we just get a minus 1 out front, x minus 1, x plus 1. Set each of those factors to 0, so we get x minus 3 equals 0, x plus 1 equals 0, so we get x equals 3, x equals minus 1. So this answer doesn't make sense. We can't have negative distance. I guess that's throwing behind us. So there we go. For D, so it hits the ground at 3 meters. So for D, at what height is it launched? Well, in standard form, if we say the horizontal distance is 0, so we haven't moved left or right yet, then we're going to get a height of 3. So your initial distance is when x is equal to 0. So if x is equal to 0, then we get y is equal to 0 plus 0 plus 3. So it's just equal to 3 is our height. Now if we want to sketch this, we have our x and y axis. We do our intercept at -1, our intercept at 3, our max height at 1, right, because we look to the vertex at 1, 5, and where initial height is 3. So you like this. There you go. There's a sketch. I'm going to leave it there to keep this video brief because so you can do all the questions that deal with these concepts, and we'll do maximizing revenue when I get back. Good luck.